Hello everyone. Today I'm going to present my carbon neutrality case report. I'm going to show you guys how to achieve carbon neutrality in hospital patient meal food waste, an illustrative Malaysian hospital food service case with BAU, project and carbon credit calculations. This case report asks how a Malaysian hospital can move its patient meal food waste segment toward carbon neutrality. The focus is consumption and waste management because uneaten meals combine a patient nutrition problem with a climate problem. I will define the boundary, show a manual calculation, compare business as usual, and project scenario with a calculator. Convert the reduction in potential carbon credits and finish with a practical 12-month implementation plan. All numerical results are illustrative until the hospital replacing the planning assumptions with measured data. Why this food system matters to me. As a physiotherapist, I often see patients leave meals because the food is bland, unappealing, or they have little appetite. This topic matters clinically as well as environmental. A single-center Malaysian study of 95 patients receiving texture-modified diets reported mean plate waste of 47.5%. Blended diet had the highest waste in that sample. Because this was one hospital and one diet group, I am not treating 47.5% as a national average. I use it as a transparent local planning signal. When the patient does not eat a meal, the embedded farming, processing, transport, refrigeration, and cooking emissions have already occurred, while the patient may also miss needed nutrition. The quantified boundary covers 1 year of texture-modified patient meals from food served through the destination of plate waste. It includes landfill and compost pathway and use 100 meals per day, half a kilogram served per meal, a 47.5% waste rate, and 365 operation days. The BAU scenario sends all waste to landfill. The project prevents 70% and composes the remaining 30%. Kitchen energy, refrigerants, and the supplier-specific agriculture remain important because they are excluded from this numerical model until measured. This prevents false precision and keeps the BAU and project comparison. The plan follows a prevention first hierarchy. First, serve the right meal, portion, and timing so avoidable waste is never created. Second, redistribute only safe, unserved surplus. Patient plate returns are not eligible. Third, recover unavoidable organic through composting or anaerobic digestion. Landfill is the last resort. Measurement energy efficiency and sustainable purchasing cut across all four stages. The key principle is that recovery cannot restore the nutrition. Money or upstream emissions already lost when an edible meal is discarded. So prevention provides the highest value. The first and foremost important mitigation measure is measurement linked to the patient-central prevention. The hospital should weight trays returned by ward, diet type, menu item, and meal period, while recording appetite, assistance needed, meal temperature, appearance, and satisfaction. It can then move ordering closer to mealtime, offer clinically appropriate portion choices, improve texture, modify presentation, and protect serving temperature. A dietitian must monitor intake so the project does not reduce waste by under portioning. The 70% target is delivery ambitious. A 2-ward pilot study should establish the locally achieved reduction before scale up. Here is the activity data calculation that established the annual material flow. 100 meals per day multiplied by 0.5 kilograms served per meal multiplied by a 47.5% waste rate multiplied by 365 days equal 8,668.75 kilograms. That is 8.669 metric tons of plate waste per year. For the RE fat calculator, the same mass is converted to approximately 19,111 pounds. These values are not claimed as measure hospital performance. They are planning inputs that must be replaced through a 4 week weighing audit. This slide applies the lesson 3 formula to one emission source, activity data multiplied by an emission factor. The annual waste mass of 8.66875 metric tons is converted to 9.55566 short tons. The US EPA food waste landfill factor is 0.68 metric tons of carbon dioxide equivalent per short ton. Multiplying them gives 6.50 tons of carbon dioxide equivalent per year for downstream landfill treatment. This is a transparent sample calculation only. It is US based and it must not be added to the IEF fat total because RE fat already includes downstream treatment. This life cycle calculator comparison used exactly the same 19,111 pounds in both scenarios. Under BAU, all waste goes to landfill and the RE fat footprint is 49.17 tons of carbon dioxide equivalent per year. Under the project, 13,378 pounds are prevented and 5,733 pounds are composted. The project footprint is 12.84 tons. The difference is 36.33 tons or 73.9% reduction. This is the headline outcome, but it remains illustrative US-based planning estimate for a Malaysian case. Redistribution is useful only for safe food that was never served to a patient. The hospital needs written eligibility rules, time temperature record, allergen information, traceability, recipient capacity, and a reliable transport arrangement. Plate returns are excluded. Malaysia Food Donor Protection Act provides conditional protection for good faith food donation, but operation controls remain essential. Donation is not included in a numerical scenario because no separate quantity of eligible unserved surplus was provided. During the pilot, the hospital should measure this stream separately so it can later be modeled without mixing it with plate waste. The unavoidable organic fraction should be sourced separate for composting or anaerobic digestion. Staff need clearly labeled food-only bins, short practical training and feedback when contamination occurs. A licensed recovery contractor should document collection distance, treatment controls, and the final use of compost or biogas. The project models 30% of the original mass going to compost after 70% is prevented. Composting is still lower in the hierarchy because it treats material after the meal's nutrition and upstream resources have been lost. It should support prevention, not replace it. These examples show why a complete hospital system combines prevention and recovery. Prevention-led service redesign menus, ordering and portion so less excess food is produced. Recovery-led service separate the remaining organics and divert them from landfill. The proposed Malaysian model uses both approaches, but it puts prevention first because it protects patient nutrition and avoids the upstream of footprint of producing food that is never eaten. The hospital should report grams of waste per meal, eatable waste percentage, treatment route, contamination, and carbon dioxide equivalent per meal, so operation changes can be compared over time. Malaysia already has enabling policy instruments, including its nationally determined contribution, solid waste legislation, food donation protection, the Energy Efficiency and Conservation Act, and the Circular Economy Blueprint. The main gap is not the absence of policy language, it is hospital-level measurement, ownership, and delivery. Food service, dietetics, nursing, facilities, infection control, procurement, and the waste contractor need a shared governance structure. The plan therefore assigns practical indicators and decision gates rather than assuming that a national policy automatically change meal service practice on a ward. Implementation is staged over 12 months. During month 0 to 3, the hospital weighs returns, maps menu, and confirms the waste route. During month 4 to 6, two ward test closer ordering, portion choice, presentation, and feeding assistance with nutrition and safety as balancing measure. Month 7 to 9 integrate production changes, safe surplus rules, and organics procedure. Months 10 to 12 scale only the measure that work. The management decision is based on gram waste per meal, patient intake or satisfaction, contamination, kilograms landfill and composted, carbon dioxide equivalent per meal, staff time and service reliability. The proposed plan reduced the scope footprint by 36.33 tons of carbon dioxide equivalent per year. Following the calculation conversion, 1 ton equals 1 potential carbon credit, so the planning estimate is 36.33 potential credit. This is not the same as automatically issued or tradable credits. A real crediting project needs an approved methodology, additionality, monitoring, leakage assessment, independent validation and verification, registry issuance, and controls against double counting. The project still emits 12.84 tons. To claim carbon neutrality, the hospital must reduce that residue further and retire an equivalent quantity of verified high integrity credits. The reference support Malaysia policy context, implementation feasibility, and hospital food waste equivalent use in the case. So that's all for my presentation. Here are the report give the full APA list and explain where assumptions are illustrative rather than measurement.